Hi, Algebra. We're going to check out lesson 4.4 and look at the slope of the line in a couple different ways. So let's check out this example. If I need to find the slope of the line shown, then I'm going to find how steep it is from left to right. So I'm noticing this line starts low on the left and ends high on the right. So this slope I know is going to be positive. So if I want to calculate this slope, I can do it several ways. Remember, we talked about lots of ways to represent slope. One of them is the letter m in the equation, y equals mx plus b. M, your coefficient of x, is always going to be your slope. But when given a graph, we need a formula to help us find that. So we can take the change in y over the change in x. So to do that from a graph, I'm going to look at 2 points on the graph. And I'm going to use these 2 points given, and I'm going to find my change in y. So looking at my y coordinates, I have a 6 and I have a 2. So I'm going to subtract those to find the difference. 6 minus 2, and that's going to be my change in y. My change in x, the x coordinates are my blue coordinates. I have a 2 and a minus 4. So I'm going to find the difference between 2 and negative 4. So as I simplify here, 6 minus 2 is 4. 2 minus negative 4 is really the same as 2 plus 4, which is a positive 6. So I'm going to simplify 4/6 to 2/3. So I'm in lowest terms, and now I have the slope of my line, which means I have a rise, or a change in y, over a run, change in x, of 2/3. So that means if on my graph then, if I start at this point, I should be able to rise 2 and run 1, 2, 3, and end up right back on my line. From here I can rise 2 and run 1, 2, 3, and I'm right back on my line. Rise 2, run 3. And I'll continue to find points on my line. Let's check out another example. So if you're not given a graph, but you're given 2 points, then we can just follow those same steps and find my slope, or m, by finding the change in y over the change in x. So as I look at my y values, I have a -1 and I have a 2. So if I start here, I can do -1 minus 2. And let's change color for my x values. I have a 4 and a 5. So I can go 4 minus 5. Notice I'm going in the same direction every time. If I start with this point to find my change in y, I have to start again with this point to find my change in x. So now let's go ahead and simplify. -1 minus 2 is -3, and 4 minus 5 is -1. Now I have a negative divided by a negative, which I know will simplify to a positive. So I get +3, or a slope, if I want to keep it a fraction to help me think of the rise over the run. Then this line, for every 3 units it rises, it would run 1, and rise 3 and run 1. So that my line would take on this kind of a shape. So in an equation, that might look like y equals 3x plus b. Let's pause and let you try this one quickly. So go ahead and pause the video while you work this one on paper. Hopefully, as you solved, you got a slope of 1/2. And to review, as we talked about in class on Friday, we can look at the slope of a vertical line, and I can examine 2 points I can look at the 0.35 on this line and the 0.31 on this line. So if I'm going to calculate this slope, I'm going to look at the change in y over the change in x. So as I look at my y values, I have a 1 and I have a 5. So I can do 1 minus 5. And as I look at my x values, I have a 3 and a 3. So I will do 3 minus 3. And as I simplify, I find a problem. I have 0 in the denominator. And for this reason, we would say that the slope of this line is undefined, because we have no mathematical definition to explain dividing by 0. So the horizontal or the vertical slope is undefined. Let's contrast that then with the slope of a horizontal line. So on this equation, if we're going to find the slope, we can use 2 points on our line, just as we've been doing. So I'll use the point -2, 4, and the point 4, 4. So to find my slope, it's the change in y over the change in x, and I will take my two y values and subtract 4 minus 4, and in the denominator I'll take my two x values and subtract 4 minus -2. And as I simplify, in my numerator, 4 minus 4 is 0. 4 minus -2 is really 4 plus 2, but it doesn't really matter because my slope is going to simplify to 0. It is okay to have a 0 in the numerator. This we would just say slope equals 0. So one practical application for slope is in a real world situation, we would call that rate of change. So when we are comparing two quantities over time, we can see the rate at which those are changing. So one example would be calories burned over time. So if I want to find the rate of change, in my head, I'm going to think, okay, find the slope of this line. Well, I don't have a graph, but I do have a table. So looking at my table, I will determine which values are my x and which are my y. Remember, your x values are your domain, your inputs, and your independent variables. Your y values are your range, your output, and your dependent variables. So in this case, the number of calories burned depends on the time I spend in activity or working out. So for that reason, the calories burned depends on the time. So I need to label my table X and Y so that I can pick 2 points, and I'm going to pick the first two to help me calculate slope, which remember in an equation will take the form of m. So I'm going to find my change in y over my change in x. So I'm going to start with y1 or y2, and I'm going to subtract from it y1. So I'm going to do 500 minus 750. In my denominator, I'm going to do 40 minus 60. And now I can simplify. As I simplify, I end up with negative 250 over negative 20. So I notice there's more work to be done. Both numbers are negative, so a negative divided by a negative cancels to a positive. I also have two numbers that are multiples of 10, so I can divide by 10, and this will reduce to 25 halves. Now, in terms of a graph, this is a great way to define the slope because I have rise over run. However, if I am looking for the rate of change, then in this case, I might want to simplify 25 halves to a decimal or a mixed number and say 12 and a half, because what I'm really calculating are the calories burned per minute. So if I'll reduce that to lowest terms and make it a mixed number or a decimal, now it makes more sense to me because not only is my answer 12 and a half, but it's 12 and a half calories burned per minute. And now I have a usable piece of information. I would like for you to do now that you have watched a few sample problems that will be similar to your class assignment on Monday, is take a second to put some of this information in your own words and explain to me in your steps how you would find the slope of a line if you are given a graph, and how you would find the slope of a line if you're given 2 points, and then take a second to write down any questions that you have over this lesson and bring that piece of paper with you to class on Monday, and we will review it together. Have a great weekend. Thanks, everybody.